Example 5 and 6, examples with ordered pairs. This is at the bottom of your notes page. So it says number 5, use a scale factor of 5 and give the new coordinates. Here's the originals. So these are the pre-image. We want to give the new ones. All right, so what we're going to do is we're going to take each ordered pair and multiply them by that scale factor. So 0 times 5 is 0, and 2 times 5 is 10. So the new figure, if it's at 0, 2 to begin with, after a scale factor 5, it will now be, the prime location is 0, 10. All right, 4, 8, so we're going to do 4 times 5, which is 20, and 8 times 5, which is 40. So the new location of 4, 8 will be the prime location of 24, 40. And the last one, 210, will now be 1050 because 2 times 5 is 10 and 10 times 5 is 50. All right, 1/4. We're now going to do a scale factor of 1/4. So this one is a reduction. So what you do whenever you have a reduction is you can multiply each of these by a fourth, or if you know that anything with a fraction with a 1 on top means that you would just divide by the denominator. So if it's like 1/4, you're dividing by 4. If it's 1/2, you're dividing by 2. If it's 1/5, you're dividing by 5. But this only works if you have a 1 on the top. If it's 2/3, you couldn't just divide by 3. It's not the same. So it only works in this case. So we're going to divide 0 by 4, which is 0. And then 2 divided by 4 is a half, so 0.5, or you can write it as a fraction 1/2. All right, let's do the next one. If the original point's at 4, 8, after a scale factor of 1/4, it will be at 4 divided by 4 is 1, and 8 divided by 4 is 2. You could also think of it as 8 times a fourth. Okay, you can do that in your calculator. And then the last ordered pair, we have 2. So 2 times a fourth is 0.5. And 10 times a fourth is 2.5. And it's okay to get some decimals on these. I know it'd be harder to graph a little bit, but you could do it definitely. It just would mean you would go halfway, so between 2 and 3 on the graph. All right, now let's apply this to a graph. So we have the next example on your notes is dilation with a scale factor of a half, and we're given this rectangle that's already been graphed, and we're already given the pre-image coordinates. So this is the original figure, rectangle A, B, C, D, and we just want to find the new ones after a scale factor of a half. So that means that we're going to multiply all of these by 1/2, which is the same thing as just dividing each number by 2. So let's give the new coordinates for A prime. Will be half of -6 would be -3, and half of 6 is 3. Let's go ahead and find B prime. Half of 6 is 3, and half of 6 is 3. C prime, half of 6 is 3, half of -6 is -3. Notice my signs, okay? And D prime, half of -6 is -3, and half of -6 is -3. So we need to plot the new one. So always start at 0, 0. We're going to go -3, +3, and this is A prime. B prime is 3, 3, so start at 0, 0, go right 3 and up 3. That's B prime. C prime is 3, -3, so right 3 and down 3. And D prime is -3, -3. So start at 0, 0, go left 3, and then down 3. And that is D prime. Connect, and there is our new figure after a reduction of a dilation of 1/2. Example number 8. This time we're using a scale factor of 2. So since it's a number greater than 1, that means it's going to be an enlargement this time. So we're going to multiply each of these original pre-image coordinates by 2. So let's find A prime. So 1 times 2 is 2, and 1 times 2 is 2. So A prime is at 2, 2. So let's go ahead and graph that one. I'm going to go right 2 and then up 2. Here's my new point for A prime. B prime is going to be at 3 times 2 is 6, and 1 times 2 is 2. So 6, 2. So start at 0, 0, go right 6 and up 2, and that is B prime. C prime, 1 times 2 is 2, and 3 times 2 is 6. So start at 0, 0, go right 2 and up 6, and that is C prime. Now this one looks different from the previous. Go ahead and connect your sides to make the triangle. You'll notice that it's not directly on top of the original. It's like in different locations. The original one was down here, and the new one's bigger, spread out in quadrant 1. So you can't just make a figure that's 3 times as bigger or double the size around it, because that's not where it's going to be. It does matter that point C prime is at 2, 6. It can't be wherever you want to just make a bigger triangle. It has to be mathematically multiply each of the original coordinates by the scale factor. And this works when we use 0, 0 as our center, okay? And that's the only way we're going to be doing dilations. When you go to geometry in 10th grade, you'll be using different centers, okay? But we're going to just use 0, 0 as our origin to dilate around, just like we did whenever we rotated around 0, 0 every time. You'll learn different rotations when you get to geometry as well. All right, and then the last one is this triangle. Go ahead and pause the video and do this one by yourself. This time your scale factor is 1/2. So you're going to multiply every original pre-image coordinate by half and give me the new ones and graph it. So pause the video, do this one on your own, and then press play to check it with me. All right, I'm going to go ahead and get everything ready to go. All right, so we're multiplying by 1/2, which means dividing by 2. So half of -6 is -3, and half of 8 is 4. Half of -2 is -1, and half of 2 is 1. Half of 4 is 2, and half of 6 is 3. So now I'm ready to plot. So I'm going to start at 0, 0 and go left 3 and up 4. And that is my x prime. Start at 0, 0, go left 1 and up 1. That is my y prime. And then 2, 3, so right 2 and up 3, that is my z prime. And there is my new triangle. Triangle x prime, y prime, z prime. How'd you do?